Assalamualaikum warahmatullahi wabarakatuh dan selamat petang kepada Encik Muhammad Fahiz. Di sini saya akan menerangkan sedikit berkenaan dengan assignment yang kami satu kumpulan lakukan. Okey, di sini saya akan terangkan berkenaan dengan introduction. In electronics, a filter is a two-part electronic circuit which removes frequency components from a signal time varying voltage or current applied to its input port. A high-pass filter attenuates frequency components below a certain frequency, called its cut-off frequency, allowing frequency components to pass through. This contrasts with a low-pass filter which attenuates frequencies higher than a certain frequency, and a bandpass filter which allows a certain band of frequency to and attenuates frequencies both higher and lower than the band. In optics, a high-pass filter is a transparent or translucent window or colored material that allows light longer than a certain wavelength to pass through and attenuates length of shorter wavelengths. Since light is often measured not by frequency but by wavelength, which is inversely related to frequency. A high-pass optical filter which attenuates light frequencies below a cut-off frequency is often called a short-pass filter. It attenuates longer wavelengths. Seterusnya kita pergi kepada teori. The basic high-pass filter is built by series connection of capacitor and resistor. While the input signal is applied to the capacitor, the output is drawn across the resistor. Okey, ini adalah gambar rajah bahagi high-pass filter. In this circuit arrangement, the capacitor has high reactance at lower frequencies, so it acts as an open circuit to the low frequency input signal until cut-off frequency Fc is reached. Filter attenuates all the signal below the cut-off frequency level. At frequency above cut-off frequency level, reactance of the capacitor becomes low and it acts as a short circuit to these frequencies, thereby allowing them to pass directly to the output. When we talk about cut-off frequency, we refer to the point in the frequency response of the filter where the gain is equal to 50%. The peak gain of the signal, 3 dB of the peak gain. In high pass frequency, gain increase as frequency increase. Okay, ini adalah graph bagi high pass filter. Cut-off frequency depends on the value of R and C on the circuit. Here time constant is T equal to RC. The cut-off frequency is inversely proportional to the time constant. Fc sama dengan 1/2 pi RC. Circuit gain is AV sama dengan Vout bahagi Vin atau R bahagi dengan Z. At low frequency, F sama dengan Xc sama dengan Xc sama dengan infinity. Vout sama dengan kosong. At high frequency, F sama dengan Xc sama dengan 0. Vout sama dengan Vin. Okey, seterusnya saya serahkan kepada kawan saya.
Okey, seterusnya itu saya Naim Iskandar akan teruskan sambungan tentang litar high pass. In high pass filter, our frequency lying below the cut-off frequency itu Fc until at this cut-off frequency point we get negative 3 dB gain. At this point, reactance of the capacitor and resistor value with the same R equal to Xc. Gain is calculated as gain dB equal 20 log V out per V in. The slope of high pass curve is positive 20 dB decade after passing cutoff frequency level. The output response of the circuit increased from 0 to V in at a rate of positive 20 dB per decade, which is 6 dB increase per octave. This is ini ialah gambar rajah seperti yang saya terangkan tadi. So the region from the initial point to cut-off frequency point is known as stop band, as no frequency are allowed to pass the pass. The region from above the cut-off frequency point, negative 3 dB, is known as the pass band. At cut-off frequency point, output voltage amplitude will be 70.7% of the input voltage. Here, bandwidth of the filter denotes the value of frequency from which signals are allowed to pass. For example, if the bandwidth of the high-pass filter is giving 50 kHz, it means that only frequencies from 50 kHz to infinite are allowed to pass. The phase angle of the output signal is positive 450 at the cut-off frequency. The formula to calculate the phase shift of high filter is omega tan 1 over 2 pi FRC. So this is the graph of the phase high pass. Transfer function. As the impedance of the capacitor change frequently, electronic filters have a frequency-dependent response. The complex impedance of a capacitor is given as Zc is 1 over Sc, where omega pi plus j omega. Omega is the angular frequency in radius per second. The transfer function of the circuit can be found using standard circuit analysis techniques such as Ohm's law, Kirchhoff's law, superposition, and H. The basic form of a transfer function is given by the equation. The equation is Hs Ks2 divide S2 plus Bs plus A, or H j omega equal j omega divide j omega plus omega plus A. The order of the filter is known by the degree of the denominator. Poles and zero of the circuit are extracted by solving roots of the equation. The function may be real or complex root. The way these roots are plotted on a plane where theta is denoted by the horizontal axis and omega is denoted by vertical axis. Reveal lots of information about the circuit. For high-pass filter, a zero is located at the origin. Hash j omega equal V out divided per V in equal to negative Z2 j omega divide Z1 j omega equal negative R2 divide R1 plus 1 divide j omega c equal negative R2 divide R1 1 over 1 plus 1 over j omega R1 plus c. Here, the conclusion of the formula is hash kurungan infinity equal R2 divide R1 gain when omega equal to infinity. That's all. I pass to my friend.
My name is Diaudin and I'll continue with the simulation part. First, the circuit that we use is, here we got the V input and it is connected in series with a capacitor and a resistor. So the output that we are trying to measure is on the resistor. The transfer function that we have calculated is 1 plus j omega divided by 6.447k. 6.447k is the impedance value for 1 over RC, which is the circuit impedance. And then we need to determine the cutoff frequency for circuit in figure 2, which is the omega C. The angular frequency in radian per second is 6.447 K radian per second, and the cutoff frequency is 1.026 kilohertz. After we have measured the output for different frequency, we will sketch a straight line approximation of the frequency response in gain decibel versus frequency for the RC high pass filter on graph 1. Moving on to the simulation, here we have the circuit which has already been drawn, and first we measure for the 100 hertz run and then stop. We measure the Vmax of the second channel of the oscilloscope. To take the measurement of the highest of the Vmax is we need to get the highest value in this channel B for V output, which is for 100 Hz it is 164.221 millivolts. And then moving on to the phase difference measurement. Here we can see that we got the time, which is 2.355 milliseconds. And then to find the phase angle, we need to calculate the time for 100 Hz frequency, and the omega time will be divided with time, which is 10 milli, and then we got and then multiply it by 360 degrees, then we get the phase angle, which is 81 degrees. Moving on to 100 kilohertz, where it is near the cutoff frequency, we can see that signal is the signal gap is becoming less, which means it is near the gain of the circuit. As we can see, the output voltage is 1.395 volts, which is near the V input, and the phase difference is a lot less than the lower frequency. In this table, I have done for every parts of the different frequencies, and you can see that the gain output that we have is becoming higher when the frequency is increased. In decibel, it will become lower. The phase angle will also decrease as frequency decrease, which means that high pass filter only allows higher frequency to pass through the circuit. As we can see on this graph, the lower frequency starts off lower and then move higher as the frequency also increase. This is the phase difference angle graph. And then we will move on to discussion and conclusion part, which will be presented by Ahmad Bashir.
Okay, my name is Ahmad Bashir. So throughout all of our experiment, we have come to know that a high pass filter is designed to pass all frequencies above its cut-off frequencies. In order for this experiment to succeed, we have designed the circuit of RC, which we create to study on how the high pass filter function in a circuit. So the step that we have done is to make sure put capacitor first and then resistor in a series. In this circuit arrangement, the reactance of the capacitor is very high at low frequency, so the capacitor act like an open circuit and block any input signal at V in until the cut-off frequency point Fc is reached. We also make sure the function generator connect to the positive terminal of our capacitor and we also put grounding for our negative terminal of resistor. Then we turn off oscilloscope and make sure to turn on two channel on the oscilloscope. These two channels should be connected on our V out so that our oscilloscope can read two sinusoidal waveform. This waveform will show a different output each time we set a different value of frequencies and beep peak to peak in our function generator. When the frequency keep on increasing, our V out will also increase. From the V output, we have to find the AV by using this formula V out divided by V in. Then find the dB by using this formula, which is 20 log times V out divided V in. This this step should be repeated again and again for each our result. For result that we get from the effect of increasing the frequency. This means the frequency response curve will show to us that the line in our graph will keep on increasing by following the result of each dB that we get. From this graph, we can find the cut-off frequency point for a first order high pass filter, which can be found using the same equation as that of the low pass filter, but the equation for the phase shift is modified slightly to account for the positive phase angle. Each of these steps should be done correctly in order to get the right result. So, in conclusion, we have learned that a high pass filter is the exact opposite to the low pass filter circuit, as the two components have been interchanged with the filter output signal now being taken from across the resistor. The passive high pass filter circuit only passes signal above the selected cutoff point Fc, eliminating any low frequencies signal from the waveform. We also have come to know that in this circuit arrangement, the capacitor act like an open circuit and block any input signal until Fc is reached. Above the cutoff frequency, any point for above the cutoff frequency point, the capacitor act like a short circuit, allowing all of the input signal to pass directly to the output. So that's all for our report assignment in advanced electrical circuit. Thank you.